Okay girls, to try and help you out, I thought that I would go through question 1 on page 65 of the SciPAD. So here we go. Let's see how we get on. So I'm going to draw in the beam here, and it is 5 meters long, and the supports are 0.5 of a meter from each end. So I'm going to call them, they're providing a force upwards. Okay, there's support A and support B. Okay, now the reason they're providing a force upwards is obviously they're stopping the beam from falling down to the ground. Okay, now, so it says a gymnast is performing on a balance beam. The beam is 5 meters long and has a uniform mass of 25 kilograms. So the weight force of the beam is going to act through the center here. And it's the weight force of the beam. And that's equal to 25 times 9.8, which comes out at 245 newtons. Okay, so that acts through the centre. And then we're also told that the legs of the beam are 0.5 of a metre from each end. So I'm going to write all those things in now. 0.5 of a metre. 0.5 of a metre. Now, because we know that the weight force of the beam acts through the centre, then we know that it must be 2 metres between here and here. Okay, so 2.5 metres here, 2.5 metres here. So it's another 2 metres on that side, and then we get the whole length of the beam across here is 5 metres. Okay, so I hope you can see all that. And then we've also got a gymnast on the beam, and the gymnast is a metre from the end. So she will be here. Okay, I'm just going to colour her in yellow. So that's the gymnast, and she has a mass of 42 kilograms. And so she also has a weight force of the gymnast, and that's equal to 42 times 9.8, and that comes out at 411.6 newtons. Okay, so that's our situation. So I've done all that before I've even looked at what I need to calculate in the answer. So part A says, on the diagram above, draw vectors to represent all the forces involved. So I'm actually going to just do that over here, and I'm going to draw a separate one so that you can see the forces. We've got what we call support force A, support force B, and then in the centre we've got the weight force of the beam. And in between there, we've got the weight force of the gymnast. Okay, so 4 forces, 2 going up and 2 going down. Okay, so in equilibrium, force A plus force B is going to be equal to the weight force of the gymnast and the weight force of the beam. That would keep the beam in the same horizontal position without it moving either up nor down. So that should be your answer to A, 4 forces, 2 up, 2 down. Part B, I'll do that over here as well. Name and describe the position where the beam's weight force was drawn. Okay, the position of the weight force is here, and it's always drawn at the centre of mass. So the weight force of the beam is drawn at the beam's centre of mass. So remember, all symmetrical objects, okay, have their centre of mass in the centre of them, and that's all the only type of problem that you see in year 12. It's the one point where you can balance the whole weight of the beam in one spot. Okay, the beam and gymnast are in equilibrium. What does that mean? So in equilibrium, forces up equal forces down. So there is no net force, and clockwise torque equals anti-clockwise torque. And what that means is that there is no net torque. And if that's the case, then nothing will move. Okay, everything stays stationary. Perfect. So that is parts A, B and C. Let's get on to part D. Calculate the size of the upward force from support B. So we need to calculate the size of this force here. FB equals, that's what we're trying to calculate. Okay, now because we need to calculate B, that gives us a clue. It means that we need to take torques about A. Okay, or that means make A the pivot point. Okay, if we need to calculate B, we're going to make A the pivot point. So let me draw that into my diagram here. Okay, and we'll make it pink, and I seem to have made all of the pivot points pink. Okay, so the pivot point is there. So everything is measured, all the distances are measured from that pink spot. Okay, now let's look at the beam to start with. If this is the only, if we pin the torque here, okay, and if force B wasn't there, the beam would come around in this direction. Okay, the only reason it doesn't come around in this direction is that force B is there. Okay, so the beam would move in a clockwise direction. So this is the clockwise torque of the beam. Okay, and what's stopping it doing that, I'm going to colour that in yellow. What's stopping that doing that is force A. So the fact that force A, or support force, is there is stopping this clockwise movement. Okay, so if this support, if this leg of the beam wasn't there, the beam would fall down like this. And it doesn't, because force B here is providing an equal and opposite anti-clockwise torque. So it's the anti-clockwise torque provided by support B. Okay, so that's the anti-clockwise torque there, provided by support B. So that's what we're going to make equal to each other. Okay, so we know that clockwise torque equals anti-clockwise torque, and the clockwise torque will be the torque of the gymnast plus the torque of the beam equals the torque of support force B. So the torque of the gymnast is 411.6. Now the gymnast is, let's have a little look. Where is she? She's 1 meter from the left end of the beam. So if she's 1 meter from the end of the beam, she's going to be 0.5 of a meter away from the pivot point, because there's your 1 meter there, that 0.5 and this 0.5. So it's 411 times, oh, not 1, by point, sorry, 411 times 0.5, because she's 0.5 of a metre away from the pivot point, plus we've got 245 newtons of weight force of the beam, and that is 2 metres away from the pivot point. Now, support force B, if we look here, is 2 metres to the centre and then another 2 metres. So that is FB, because that's what we're trying to work out, is 4 metres away from the pivot point. Okay, so if we work out this side, we get 695.8 equals 4FB. And if we divide both sides by 4, we're going to get 173.95 newtons, or 174 newtons. That's force B. Okay. As you can see, these are excellence questions. So if you're struggling with this work and you are not feeling confident maybe with the work from last lesson, go back and just work on that. Okay. Part E here says the gymnast moves so that she is now 2 metres from support A. Outline how this affects the sizes of the forces supplied by supports A and B. So if the gymnast moves from here to the centre, because if she's 2 metres from here, 2 metres from support A, she's now in the centre. So if she moves to the centre, and I'll just draw a tiny little picture here, we've got support force A and support force B. And if we've got the weight force here of the beam and the gymnast in the centre, then obviously both of force A and force B are going to be equal, okay, because this whole weight force is going to be divided equally between the 2 legs of the beam, or the 2 supports of the beam. Okay, so I think we just need to say here FA would equal FB and would be half of the total, which is 695.8, and so that would be 345, 348, 347. Let me just, can't do my maths in my head. 345 and 2.9 is 347.9, 348 newtons each. So they would each provide half of the force. Okay, so hopefully that will help you on page 65. Okay, again, as I said, if that is too hard, oh, I can't see it. Hopefully, good luck with that, girls.